Good afternoon, everyone. Welcome to Architecture Session 218. This is about Google Cloud Storage, also commonly known as GCS, which is the planet scale storage optimized for AI workload and cloud-first workload. My name is Jason Wu. I lead the cloud storage product team. Joining me today, we also have Sridevi, who is the Senior Engineering Director for Cloud Storage. We're also very excited to have three distinguished customers joining us today. Sachin from Priceline, Jack from Nuro, and Ugur from Codeway. We have a very packed agenda today. I will first give a little context about the cloud storage, why choose Google Cloud Storage. Then we'll move on to some of the new product announcements we have. After that, we'll have customers covering, sharing about how they're building innovative AI solutions on top of cloud storage, from large-scale AI ML data pipelines to Gen AI model training and serving on top of cloud storage, to enterprise AI with a delightful customer experience. After that, Sridevi will share about our future product vision for cloud storage with Gen AI. And at the end, we'll have some time for Q&As as well. All right, so what is cloud storage? A quick primer. Cloud storage, also known as a GCS, it is highly available, cost-effective, durable, and simple to use object storage. Many customers using cloud storage for store and manage large amount of unstructured data. There are a few key differentiators for Google Cloud Storage. The first one I'd like to highlight is simplicity. We offer 4 different storage classes, from standard all the way to archive. All of these storage classes, they share the same set of API and provide instant access, even for accessing archive storage. This is very different from a lot of the archive storage product out there in the market, which oftentimes requires a customer to rehydrate the data, and then you can access the data, which normally takes hours to do it. And for us, it's all instant access with the same API, so this dramatically simplifies application development. Even for some of the very advanced capabilities, such as geo-redundancy and business continuity type of capability, Google Cloud Storage offers a dual region and multi-region product, which we offer to store 2 copies of your data over 2 or more of the different regions. With that kind of a multiple copy of the data, we still provide a single global endpoint with a strong consistency, as well as with automatic request routing and failover, failback. So application can interact with the dual region and the multi-region product the same as they're interacting with a regional bucket. Reliability is another area which is super critical to enterprise customers. With cloud storage dual region and the multi-region, we offer the highest availability SLA for both read and write. With dual region and the optional turbo replication capability, we also offer the best RPO and RTO in the industry, with 15 minutes guaranteed RPO and 0 minutes for RTO. Cloud storage is also optimized for data-intensive workloads, such as AI and analytics, with its high throughput and QPS. We also offer incredible scalability. We have customers today running exabytes of data with trillions of objects, or even from a single bucket. And cloud storage is built with secure by design to begin with. and which offers a wide range of security capability to allow our customer to meet their security and compliance requirement. There are many use cases cloud storage is well suited for, particularly for AI workload. In the last couple of years, we have seen this dramatic increase of use of cloud storage for AI workload. With its high performance, programmability, and manageability, which make cloud storage well suited for these Gen AI workload, both for model training as well as for model serving. Running data-intensive analytics workload is another common use case. We have customers using cloud storage for large-scale data processing and large-scale data analytics, where they can get the high throughput and the low latency out of their data. We have some world's largest content providers using cloud storage for storing their content and serving their content from cloud storage. And backup and data protection has always been a major use case for cloud storage as well, especially with a low archive storage price, combined with instant data access all the time, make it ideal for a lot of the disaster recovery and the data backup purpose. So next slide, I'm going to cover a lot of the new capabilities we're launching to make the cloud storage you know and you love even better. We have spent a lot of time to optimize storage, optimize the cloud storage for the AI and analytics workload. In the areas of programmability, we're launching cloud storage fields with transfer for HDFS, as well as a POP-sub to cloud storage subscriptions. Cloud storage fields allows customer to mount and access their data from a GCS bucket, from a cloud storage bucket, as a local file system. It also fully integrates with GKE, so that with this, it dramatically simplifies the AI workflow for training and inferencing. In the areas of performance, we're introducing anywhere cache with as well as a gRPC API and the performance improvement for Hadoop connector. Anywhere cache is a zonal SSD-based cache, SSD-based read cache, which is designed for data-intensive workload. Combining anywhere cache with our unique offering of multi-region, customer can get this ultimate data placement flexibility, as well as the ability to co-locate the data with their compute resources in anywhere in the multi-region. So this offers an ideal data storage infrastructure for a lot of the customers building a single unified lakehouse on top of it. In the areas of manageability, we are launching manager folders as well as event-driven transfer. Manager folders allows the customer to group a set of objects within a bucket and set permissions and access on top of on that group. So this simplifies a lot of the data management for AI and analytics workload. In addition, we continue to invest to make cloud storage even better for enterprise and mission-critical workloads. For intelligent storage, we are introducing storage inside the dataset, which allows customer to query their storage object metadata, get insight directly using BigQuery. With the auto class, which helps the customer to manage their storage and doing cost optimization based on how frequent the data get accessed. We're expanding auto class to include all of the, your data, including all of the existing buckets for where you have your data stored. We're also introducing a number of security and compliance controls to help our customer to better meet their security and compliance requirement. And the last but not the least, we continue to make the already awesome reliability and scalability even better. We're launching soft delete, replication monitoring, as well as customer dual regions for both Canada and Australia. Soft delete is a key capability to help customers protect themselves from these accidental operation errors. I think many of us probably had the experience where we accidentally delete some of the object and then only realize that a couple of days later. With soft delete, you will be able to recover those deleted objects very easily. I know that I run through a large number of new product announcements very quickly. A lot of these new products are available today, and you can try it, and you can look into that now. And some of them will become available in the months ahead. In the next few days, we'll share more details about each of those features, and we're very much looking forward to working with you and having you try them out. With that, I would invite Jack to the stage. Jack is going to share how they're building innovative AI and autonomous driving solutions on top of cloud storage. Jack, thank you.
Okay, thank you. Thank you, Jason. Hi, I'm Jack. I'm head of autonomy infrastructure at Nuro. So today I'm going to talk about what data and AI at scale at Nuro looks like, what the challenges that we encounter, and how we partner with Google Cloud Storage to resolve some of those challenges. So at Nuro, our mission is to better everyone's life with robotics. And we're building autonomous driving technology as well as the customer robots for goods delivery. We have been partnering with Google Cloud for more than 5 years. We're a heavy user of cloud storage, compute engine, and GKE. So for my org, the goal is to accelerate the development of autonomous driving technology with an ML-first strategy, with a focus on developer productivity, cost optimization, and operational efficiency. So what does data and AI at scale look like? So basically, long story short, we're dealing with a massive amount of data. So there are a few sources of data. Like one major source is the on-road data collection. We have a fleet of vehicles and robots that's driving on the road and collect a lot of data. And we have high-resolution sensors like multiple cameras, LiDARs, and radars continuously collecting data at about a few hundred gigabytes per hour of driving. So you can imagine the amount of data quickly accumulate. And we don't want to throw away any of our data because we identify the failure modes of the autonomous technology, and we want to do some data mining to mine some interesting scenes from the corpus of data that we collect in order to use them for training or evaluation purpose. The second source of data coming from simulation. So simulation is a digital twin of on-road testing, so we use simulation extensively to test our autonomy software before we put them on road. So we're talking about exabyte of scale of data here, and when we run large-scale simulation, we're often dealing with terabits per second of bandwidth. So when you're dealing with a massive amount of data, we encounter challenges like the cost of storing all this data, and also like the bandwidth throughput for some large workload like simulation, and some security side of considerations like security and governance. So how do we partner with Google Cloud Storage to solve these problems? So before we partner with Google Cloud, we have an on-prem data center that we store our data, and constantly we have to fight with ever-growing the amount of storage and also reliability issues. So when we migrate everything to Google Cloud, reliability is extremely good, and we don't need to worry about it, and the scalability is also great at a good cost effectiveness. The other thing I think Google Cloud did really well is a really good developer experience. It provides a very unified API, very easy to work with. So what are the features we're looking forward for cloud storage? So first one is AutoClass, as Jason just introduced. So AutoClass is a way to automatically manage the lifecycle of data and move them to cheaper storage layers. So we don't need to spend a ton of engineering effort to optimize the lifecycle of the data and actually spend more useful engineering resources on developing our autonomous driving technology. And the second feature is anywhere cache. So we want to bring our data close to our the GPU compute so that we are not bottlenecked on the data I/O and have a high GPU utilization. So the third feature is managed folders. So we want fine-grained control of the security, fine-grained access control at below bucket level. So super excited and look forward to a lot of features that GCS offers for us. So next, I'm going to hand over to Ugur at Codeway to talk about Gen AI and cloud storage.
Sound check. Thanks, Jack. Hello, everyone. Thanks for joining. My name is Ugur Arpacı, and I'm working as a lead DevOps engineer at Codeway. So I will be sharing our experiences with Google Cloud Storage with the integration of GCS views on top of GKE today. So Codeway is a startup company. We were founded back in 2020, so we are like 3 years old company. But we already scaled our products across like 125 million users all around the world. And we mainly focus on AI products. The sole purpose of our company is providing these models as much user as possible globally by productionizing it, giving some unique products. And Google Cloud is really our main infrastructure provider. And since we are dealing with big data across different products, also we are dealing with different AI models, we really don't want the data to be another challenge for us. So this is why from the day one, we're always using the cloud storage. But today's example will be on a specific product called Voi, which has the GCS views integration with it. So this specific use case is for an application called Voi, and we always produce mobile applications. And Voi is an AI-based portrait maker application. Basically, we ask some users, we ask for some headshots from different angles, different lighting conditions, the color conditions. And we take that from the application, and then our GKE cluster basically create an training pipeline as soon as we have these images. And training pipeline is handled by a specific pod in the cluster. And this cluster is running, of course, on GKE. And we are using lots of spot instances with different kind of GPU accelerators on top of that. So for this specific app, we are mostly using A100 GPU accelerators from NVIDIA. So the entire architecture is working as event-based. As soon as we have the images, we store them on GCS bucket, which triggers a training pipeline. And as soon as training is finished, we actually create a unique model for each of our users. So we don't have a generic model, but we have more like dedicated model for each of our users. So where the GCS views add the value is actually on the step 4. As soon as the user has the trained model, they can ask some specific, let's say, visual. Let's say they want to see themselves as a Greek god, let's say. So we take that as prompt. As soon as user demands this, an inference workload starts at this time. So that means we need to fetch this AI model and then put it on a pod for inference this time. But the challenge is, of course, user wants this multiple times, not just one. That means we need to fetch this model multiple times as well. So we need really like an abstract layer of storage so that our stateless pod can work with it. If you think about this step 4, if we don't use the Google Cloud Storage, what would we do? We would use preferably a CLI to fetch the image like GSUtil. But then we also need to know, we also need to cache this data on specific pods. So this is where the challenge starts. If we want to implement this without the GCS views, we will probably use lots of persistent volume claims. That means we need to manage the storage as well. But with the GCS views, this is really like a distributed abstract layer, and we just ask the user's model so that we can run an inference. And as soon as we have this output image, we publish it over the Google CDN to the end user. So what is the results out of this we get? As I said, it really provides an abstract layer of storage. Also, instrumentation is very easy. You just add certain annotation to your Kubernetes manifests. And you control access on the pod level by creating and attaching a service account on your pod. This will immediately inject a sidecar container inside your application pod, which controls access to the Google Cloud Storage itself. So you really have pod level security. This is also covering our security concerns. And also, this application actually reaches its first million users within 6 days. So as a startup company, scalability is really one of the challenges, especially for the DevOps team. But with the powerful functionality with GCS views, we only focus on improving the AI model we have. And yeah, with that being said, I'm passing to Sachin. Thank you.
Thank you. Thank you, Hugo. Hello, everyone. It's an honor to be here today speaking at Google Next. My name is Sachin Menon, privileged to serve as the Vice President of Data and Marketing Technology at Priceline. Priceline, as you may all know, is a leader in online travel for over 25 years, with a mission to be one of the best travel deal makers in the world. And this lets us fulfill our purpose of helping our customers experience the moments that matter. In my capacity as head of data, my foremost aspiration is to optimize our data platform for speed and reliability. Concurrently, we also wanted a cutting-edge real-time data framework that empowers well-informed decision-making and personalized user experience. Furthermore, it was critical to harness the full potential of our data lake architecture, enable large-scale machine learning initiatives, and drive innovation. In our data platform modernization journey, we prioritized both proper data storage solution as well as efficient platform management in terms of operations and cost. Our criteria focused predominantly on scalability, durability, and optimization. Among the options, Google Cloud Storage stood out by embodying these qualities and seamlessly integrating with a range of services and processes that we wanted to accomplish. As depicted in the architecture diagram on the left, Google Cloud Storage serves a central role as a data lake, facilitating seamless analytics, machine learning, and crucial operational functions. A parallel priority for us was optimizing cost. Through integrated features like storage insights and auto class, we gained the ability to identify usage trends, empowering informed decisions and enhance cost efficiency. Looking ahead, we are focusing on 3 important use cases or areas for using enterprise storage in AI and analytics. We are leveraging the integration of Vertex AI and GCS together to create a personalized travel concierge to harness the power of personalization and recommendation and improve the customer experience in all. We're also using GCS and GenAI to search, share, and reuse internal data assets, which makes our team more collaborative and productive. The last one, the third one, GCS helps us with also the predictive analysis while maintaining the security features of certainly, and providing real-time insights, giving us better visibility into the data. These efforts highlight our dedication and commitment to fully leverage the capabilities of our enterprise storage layer in the realm of AI analytics. With that, I'll hand over to Sridevi for the next session.
Hi, everybody. I am Sridevi. I lead engineering for GCS. We'll be shifting gears a bit. We have been talking about so far as how GCS can actually help our Gen AI customers or AI ML customers. Here, we want to talk about how maybe we can use Gen AI ourselves to improve storage. So we have been thinking about this for some time, and one of the big problems that we identified was storage management. As you know, a number of our customers store billions, if not trillions of objects on GCS, and storage management is actually a huge problem. We have just announced the Insights data sets, which is like take all of our metadata, put it in BigQuery, and enable you to gather insights using SQL. But can we do more? We have Gen AI at our disposal. Can we do more? So one of the things that we have been thinking about is maybe we can do something like natural language. Why SQL? Why limit ourselves to SQL? The next one is why only metadata? We should also think about data, metadata, logs, your context, your security, and GCP policies. Then instead of just waiting for you to ask questions, we should probably be thinking about the outcome. What is the user trying to do? And kind of try and do that instead of waiting on checklists, et cetera. The other one is instead of like having you run all these commands, can we automate all the repetitive tasks? So that was the goal that we set ourselves with. And at this point, I'd like to share a prototype that we have built using Vertex AI Model Garden and the Duet AI, like AI safety practices, et cetera. Again, just calling out, this is proof of concept. Unlike all the other launches, we don't have commitments yet, but we are definitely looking for some feedback. So you come into the GCS UI, you see all of your buckets and objects. We'll try and give you a snapshot of your project, which is relevant to you. So here in this case, it talks about how you have your project and it has so many objects of data, et cetera. You say, OK, tell me more. Now it can actually show, based on your data, kind of, hey, this is the right way to generate the chart, right? So kind of show where your buckets are, where is your data in each region. Then it suggests some prompts that may be useful to you, right? Or you can enter your own prompt. So one of the things is, oh, do you want to know which buckets are growing fast? OK, so you click on that. Then it actually shows the buckets that are growing fast. Then it again suggests, oh, maybe you want to know, which buckets actually have no life cycle rules. This is important, right? Like, oh, you're not managing your storage. So you can click on that, and then it actually says, these are the buckets that don't have life cycle rules, and do you want to fix that? And it can suggest the command that can run, and for extra measure, actually tells you that this has added cost. Right? And it can actually run the command as well if you give it the permissions. So this is kind of the experience that we are shooting for. But what was more interesting? This is, as you can imagine, most of the data that GCS has, GCS documentation, knowledge base, et cetera. Most of our customers actually have compliance rules that they have to follow based on their own company rules. So what if you can actually upload your security requirements document and ask Insights Gen AI, how am I doing on my bucket, right? So then it can synthesize your document and look at the GCS data and say, OK, based on your document that you have uploaded, all your buckets should not be publicly accessible. That means no bucket has to be publicly accessible, and you should have CMAC protection setup. This is customer managed encryption key, etc. So it actually suggests what you should be doing on your bucket. So hopefully that kind of gets you excited, as we are excited about this, and hope we can do more. So we do believe that AI-enabled storage is near. And as you can see, one of the nice use cases is to combine all the data we have with us and create multi-turn chat experiences, customized charts, and code generation and execution. This is just the tip of the iceberg. I think more will come as we go on. All right, I think we are at the end of the talk here. Hope all of you have learned something about GCS.